All right, going over the second problem set for Chapter 8, starting with some factoring. So we're going to do a box and diamond. Got k squared and 20. That gives me 20. K squared needs to add up to negative 12k. In order for this to be negative and it multiplied to a positive, they both need to be negative. So two numbers that would, negative numbers that would multiply to 20 but add to negative 12 would be negative 10 and negative 2, both with a k. And then we'll have a k and a minus 10 and a minus 2. So my answer here is k minus 2 times k minus 10. Oh, and on this one, some people wanted to know if that 2 there would count as a common factor. It doesn't. The coefficient in front of the k is like a 1. So 1, 12, and 20 only have a common factor of 1, which doesn't really change anything. So you don't get to count that 2 as a common factor. All right, next. This one also does not have a common factor because 6, 17, and 14 don't have a common factor. 17 is prime. If it has a prime number in it, you know you're not going to have a common factor. And 6x squared minus 14, negative 84x squared, and 17x. So factors here were a little bit tricky. So I've got 84 and 1, 42 and 2, 28 and 3, 21 and 4. I know one of them needs to be negative to make it a negative up here. And if I subtract these, I could get a 17. So that means the 21 is positive and the 4 is negative. Now I need some common factors. This would be a 3x and a 2x. That would need to be a 7. That would make this a negative 2. So 3x minus 2, which I guess I could do it up here. 3x minus 2. And 2x plus 7. All right, on C, I just want to show you how on some of the ones where if you have a coefficient of 1 here and the numbers look relatively friendly and you're someone that really doesn't like having to draw out the box and diamond, I'm just going to show you the way that I learned how to do it. So what I was taught was that just right underneath, you write the parentheses, like what you know it's going to look like. And then since this is going to be an x squared, you fill in an x and an x. And then you know that you need two numbers that multiply to 16 and add to negative 8. This only works if there's a 1 in front of the x squared, right? If there's not a 1, then you have to like fill in the other numbers there and then think about like what would multiply to make it work. It becomes much like it's easier just to do a box and diamond. But if a 1 out there, then all you need to do is think two numbers that multiply to 16 and add to negative 6. Well, if they add to negative 6, they must both be negative. So negative 4 and negative 4 would multiply to 16 and add to negative 8. By all means, continue doing the box and diamond. I love box and diamond. Some of you have been asking me, though, about a way to do it without. And then on D, 9m squared minus 1. So here, this is one of those ones that's missing a term. But that's okay. It's just going to be a 0. So you're going to do 9m squared, negative 1. That gives me negative 9m squared and 0m down below. So what would add to 0? Negative 3 and 3 would do the trick. So it'll give me 3 and 3, minus 1, 3m, 3m. So 3m minus 1 times 3m plus 1. And both of these here, this one is called a difference of squares. And you can see that from right here. 9 and 1 are both square numbers and they're being subtracted. It's the difference of squares. And here on C, this is a perfect square because it could also be written as x minus 4 squared, right? It's not a rectangle, it's a square. Both sides are the same. All right, 33 was tricky. First couple weren't. plus 10 plus 10, 2x equals 10, x must equal 5, and x equals negative 6. But then they throw you a loop. On C, they say, but what if they're together? 2x minus 10 times x plus 6 equals 0. Well, we know that anything times 0 makes 0, right? 15 times 0 equals 0. So if I put a 5 in here, so 2 times 5 minus 10, and then 5 plus 6, that'll give me 10 minus 10 times 11. Is this going to be true? 0 times 11 equals 0? Yes, it is. True. So x equals 5 works. I can also try it with negative 6. 2 times negative 6 minus 10 times negative 6 plus 6 equals 0. Negative 12 minus 10 times 0 equals 0. Negative 22 times 0 equals 0. This is true, so x also equals negative 6. So if you can figure out where each of those, when each of the multiples equals 0, you can find both the answers. So there's 2 answers here for part C. Let's do it again for 34, or for D, E, and F. So when you solve D, 4x plus 1 equals 0. X would equal negative 1/4. For E, x would equal positive 8. And then you can plug those in for F. So 4x plus 1, x minus 8. I'm not going to do all the plugging in again, but hopefully we can see that if I put a negative 1/4 in here, this whole thing would be 0. So x can equal negative 1/4. Or if I put an 8 in here, this would be 0, which would make the whole thing 0, which would make it true. So x could also equal 8. That's all you need to do. All right, 34. First of all, I kind of made a mistake on B. That should read calculate and interpret R in context. Okay, just pretend it says R. Don't do the R squared. So for 34A, interpret slope in context. So the slope here was negative 0.55, and we're talking about how many quarters of high school versus the backpack weight. So we'd say for each quarter, the weight goes down by about half a pound. Oops. For B, we could interpret the R as saying that it is a moderate association. For C, the residual with the greatest magnitude is 17.66. And just kidding, that was a value, not a residual. So for the residual, I would look at the graph right here, and I would see that that number right there is the furthest away. And so that is after 3 quarters. So that's the point 3.56. And looking on the graph, we can see that one is way below expected. So I'd say 3.96 has a residual of, and then we would calculate it because the little graph is too small for us to actually see what it is. So we find the predicted by using our equation and plugging in our x value of 3. So I'm going to do 13.84 minus 0.55 times 3. and that gives me 12.19. And we remember that residual is actual minus predicted. So that's going to be 5.96 minus 12.19, which gives me negative 6.23. For D, they're wanting us to make another prediction, this time with 10. So we're going to do y equals 13.8, 4 minus 0.55 times 10. That gives me 8.34 would be the predicted weight. And we have to decide, is a linear model best? This one's close, but if you look at it, it does kind of look like there's a little bit of a V shape here, right? The way there's like no positive residuals in the middle. There's like positive residuals at the beginning and positive residuals at the end, but there's this like open spot of them. Like it sort of looks curvy. It's a little bit hard to tell, especially because the association is so poor, but I would say that a curve model might be better. Because of the V shape in the residual plot. All right, in 42, do we substitute 0 for x, or do we substitute 0 for y if we're trying to find the x-intercept? Well, we know that the x-intercept would be like at a coordinate, if the x-intercept was 15, you'd say 15, 0. So that means that y is 0. So it should be when y equals 0. So 0 equals mx plus b. So if 0 equals 0, that means Michelle is correct. Good job, Michelle. And we're going to find the x-intercept of negative 4x plus 5y equals 16 by putting in 0 for y. So negative 4x plus 5 times 0 equals 16. Negative 4x equals 16. X equals negative 4. So I guess I would write as a coordinate. Negative 4, 0. All right, on 43, we need 3 consecutive integers. That means they're all lined up, whose sum is 138 by writing and solving an equation. So let's say the first integer is x. The second integer would be x plus 1. Third integer would be x plus 2. I want the sum of those 3 integers, so I'm going to do x plus 1 plus x plus 2 equals 163. And then I need to solve that. Well, I could combine like terms. 3x plus 3 equals 163. And then I can solve. So x would equal, oh, haha, just kidding. It's not 163, it's 168. No wonder that wasn't coming out pretty. 168 minus 3 would be 165. That's going to be much better. It gives me 55. So the 3 integers would be 55, 56, and 57. Okay, and on 44, we need to do some matchy-matchy here. So these ones both have a negative 2 for the y-intercept right there. So that means that 1 must match with C because it's the only one with a positive y-intercept. So, sorry. So 1 matches with C. That leaves me with A and B matching with 2 and 3. The only difference there in the rules is that negative x squared. And when you have a positive x squared, that gives you a parabola that goes up. When you have a negative x squared, that gives you a parabola that goes down. So A would match with 2 and B would match with 3. So 2 would be A and 3 would be B. And they wanted me to explain. So 1 to C, we'd say negative y-intercept. For 2 and A, we'd say negative x squared and downward parabola. And for 3, positive x squared, upward parabola.